All right, ladies and gentlemen, we are on notes 9.1, and we're taking a look at scatterplots and lines of best fit. So, let's first of all define a lot of vocabulary. We have 4 vocab words that we need to define. The first vocabulary word is qualitative or categorical data. So what I'm going to have you do is write down the definition that you're about to see. If you need to press pause for any of these vocab words, make sure you do so. All right, so qualitative or categorical data. These two words are synonymous with each other, which means that they mean the same thing. All right, so it's just data based on descriptions or categories. So an example would be if you were to collect data on people's eye color. What are the eye colors of the students in Red House Math 8 classes? So you would say that eye colors are your qualitative or descriptive data, because when you give me answers, you're not going to say numbers, you're going to give me descriptions. Your answers are going to say like brown, blue, green, whatever color your eye is. You're not going to say that the color of my eye is 7, for example. Okay? All right, quantitative data is data that's based on numbers. So an example of that would be your age. When you ask somebody what their age is, you give them a number. Your age is 15. You've lived for 15 years, okay? Or your weight. When somebody asks you what your weight is, you would give a specific number. So now you might be like, well, how am I going to remember the difference between qualitative data and quantitative data? Well, all I have to do is think about whether it is a quality, which is a description, or is it a quantity, which means that it's a number, okay? All right, your next vocabulary word is bivariate, and you might be able to figure out what this word means. Bi means two, like a bicycle, right? If you have a bicycle, it means that you have 2 cycles in it. So bivariate, the word variate comes from the word variable, so bivariate means 2 variable data. So last year when you guys did statistics, your statistics unit, you guys learned about 1 variable data. This year we're going to talk about 2 variable data, and the 2 variables could either be qualitative data, which is what we just talked about right here, or quantitative data, okay? And in today's lesson we're only going to be talking about quantitative bivariate data, all right? And then the last word is outlier. And it's literally what it says, outlier. It's a data point that's outside of the general trend. So they're data points that are outside of the general trend. All right? All right, the next section asks you to describe the association between the bivariate data shown in each scatterplot. So let's see why it's bivariate. It's bivariate because you've got an x variable and a y variable, so you've got 2 variables. And then an association, it says an association can be strong or weak, positive or negative, and linear or nonlinear. So let's look at graph A. This appears to be a strong correlation, a strong relationship, because it's following a general trend right here. And if I wanted to, I could use a line to describe the general trend, and each one of my data points is pretty close to the line, okay? So I would say that this is a strong association, all right? And then it's, so I know it's strong. Is it positive or is it negative? Well, it's decreasing, so it's going to be a negative association, okay? And then it's asking you if it's linear or nonlinear. Well, it appears to follow a general line trend, so we would say it's linear. So if the trend, this is called right here, what this is called right here is a trend line. So this green piece that you have right here is called a trend line, and this trend line that you have here is linear. Okay, as opposed to another example that you'll see in a couple minutes that's nonlinear. So graph B, I want to know, is this a strong or a weak correlation, a strong or a weak association? Well, there's no really general trend, right? There's nothing specifically that's happening, so it's really hard to tell what the trend is. So here, we're not going to say that there's a strong correlation. We're going to say that there is a weak correlation. So then I can't really figure out if it's positive or negative, linear or nonlinear, okay? And this is another example right here. It's kind of hard to tell what's going on right here, so we're going to say that this is weak. And then the last one that we have here, there is a correlation, and if I were to draw something in to represent what it looks like, if I were to draw my trend line, this time all the data points are really close to this green function that I'm graphing out right here. So there is a strong correlation, and it's going up, so we're going to say that it's increasing, all right? But if you notice, the green trend line that we have here is not an actual line, it's a non-linear function. So here we're going to say that it is non-linear, all right? All right, so let's take a look at the example that we have here. It says, the table below shows the predicted annual cost for a middle-income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. So right here, this is our independent variable. It's our x variable. So the age of the child is independent, and the cost depends on the child's age. So that's the dependent variable, it's the y variable. So when the child is 3 years old, so if you look right here, we've got age in years, and then we've got annual cost in thousands. So when the child is 3 years old, it costs $10,700 to raise the child when they're 3 years old each year. So I'm going to go to 3 years on my x-axis right here, and I'm going to go to 10.7 on my y-axis because this is $10.7 thousand. It's $10,700. So I'm going to put a dot right there, and there's my first point in my scatter plot. A scatter plot is literally what it means, a plot that is scattered, okay? So when the child is 6 years old, right here, it costs $11.7. So I'm going to say 6 years old is $11.7. I'm going to put a dot there. Next, I'm going to put a dot at 9 years of age and $12,600. Okay. 12 years of age costs $15,000. And then 15 years of age costs $16,700. So that's where I'm going to put this dot right here. Now, if you notice, it's not a perfect linear function because things might vary between the different years, and it's an average cost, okay? So we don't draw an actual line. We don't connect the dots. This doesn't make sense at all. So do not connect the dots. I repeat, do not connect the dots. So this is our scatter plot. We're done. We've drawn in our scatter plot. And then it says describe what relationship exists within the data. So what is happening as the child is getting older? Well, as the child is getting older, the amount of money it costs to raise each child is increasing, okay? So the relationship is that as age increases, cost to raise the child also increases. Okay? All right, so now we need to define what a line of best fit is. Well, a line of best fit is literally just a line that represents the data the best. And another word for it is a trend line, and we talked about that when I was showing you the examples at the top of our page right here. When we drew in our green lines right here, these lines show the general trend of the data that is shown right here. So these are general trends. So if you take a look at this example again that we did right here where we drew our scatter plot, I can draw in what I think would be the line of best fit, the line that best fits the data. And it appears to me that it would look something like this. okay? And your line of best fit should show you, it should go somewhere in the middle of your data values. So you should have approximately the same number of data values above and below the line of best fit, okay? So that's how you figure out your line of best fit. Next year, you're going to be doing a lot more stuff more in depth with lines of best fit, and you're going to have calculators that give you the exactly perfect line of best fit. There's no guesswork at all, but for right now, we're just going to approximate where we think the line of best fit should go. All right? Now, the whole point of a scatter plot is to have a line that best describes the data so that we can use it to help us predict what a certain outcome would be based on the data that we have here. So in this example, we have yield of a chemical reaction. So it's obvious that as the temperature is increasing, the yield in grams is going to decrease. So as the independent variable increases, the dependent variable decreases. So generally you would draw in your line of best fit approximately where you think it would be. But this is drawn in for us, and if you notice, it's drawn in such a way so that the line goes through the data and it's a good description of the data. That's why it's called a line of best fit. It best fits the data. So how do I find the equation for a line of best fit? All I have to do is pick 2 points on my graph and find the equation of those 2 points. Just like we learned when we learned how to find equations of lines. So I'm going to choose 2 points on my graph. The first point I'm going to choose is this point right here. It's clear that the point is at 55 degrees Celsius and 22 grams. So this coordinate right here would be 55, 22. And then I would do the same thing for my other coordinate right here, and this coordinate appears to be 65, 20. So I'm going to plug it into my slope formula. So I'm going to do y2 minus y1. So I'm going to say 20 minus 22 over x2 minus x1, 65 minus 55. I end up getting negative 2 over 10, which is negative 1/5, which makes sense. As the temperature increases by 1 degree, the yield will decrease by 5 grams. Okay, so that's the m. Then I would just use y equals mx plus b to find the starting amount. So y equals mx plus b. And I know that the m is negative 1/5, so I'll use negative 1/5 right here. And then I'm going to take any coordinate I want, plug it in. I will choose 55, 22, so I will plug in 22 for y. And then I will say equals negative 1/5 multiplied by 55 plus b. And here, to figure this out, I'm just taking 55 and dividing it by 5, so I would get 11, but it's a negative 1/5, so I would get a negative 11. So I end up getting 22 equals negative 11 plus b. Okay, then I would add 11 to both sides, and I would end up getting 33 equals b. All right, so that means that my equation for my line of best fit would be equal to y equals negative 1/5 x plus 33. Okay. Next time I see you in class, we will talk a little bit more in depth about this equation, because there's something that you should notice that is a little bit strange, and we'll talk about why it's strange. And we will also answer questions 2 and 3 tomorrow in class. Okay?